Ever wondered why lemon tastes sour and soap feels slippery? What if I told you it's because of something called acids and bases? Yes, that's right. These aren't just terms you hear in a science class. They're everywhere around us, shaping our experiences and interactions with the world. From the tangy taste of a ripe orange to the soothing feel of a moisturizer, acids and bases play a significant role. So, buckle up as we dive into the world of acids and bases. Acids, they're not just in your citrus fruits, but they're more common than you think. In the realm of chemistry, acids are defined as substances that donate protons or hydrogen ions in a solution. They have distinct characteristics that make them easily identifiable. One of these is their sour taste. Ever bitten into a lemon and experienced that sharp, tangy taste? That's citric acid at work. Acids also have the unique ability to turn blue litmus paper red. This is a classic science experiment that you may have encountered in a school lab. It's a simple yet effective way to test if a substance is acidic. Now, let's talk about how acids react with metals. When an acid comes into contact with a metal, it causes a reaction that releases hydrogen gas. You might have seen this in action if you've ever observed a piece of zinc fizzing and bubbling when it's dropped into hydrochloric acid. Speaking of hydrochloric acid, this is actually one of the most common acids around. It's naturally produced in our stomachs to help with digestion. Then there's acetic acid, the component that gives vinegar its sour taste. And let's not forget about citric acid, the reason behind the tartness of your favorite citrus fruits. In essence, acids are proton donors. They're the reason behind the tangy taste in your mouth when you bite into a lemon. Now, let's shift gears and talk about bases. Remember the slippery soap? That's a base. Bases in the world of chemistry are substances that can accept protons or donate pairs of electrons. In simpler terms, they're the opposite of acids. Bases exhibit certain characteristics that make them stand out. For instance, if you've ever tasted a base, not that we recommend it, you'll notice they have a bitter taste. One of the most fascinating properties of bases is their ability to turn red litmus paper blue. That's right. This is because bases react with acids, which are known to turn blue litmus paper red, neutralizing their effect. Another telltale sign of a base is its soapy feel. That slippery sensation you get when you're washing your hands. That's due to the bases in the soap. Common examples of bases that you might encounter in everyday life include sodium hydroxide, which is used in various cleaning products, magnesium hydroxide, commonly found in antacids for heartburn relief, and ammonia, which is a key ingredient in many household cleaners. So, next time you feel the slippery sensation of soap or see red litmus paper turn blue, remember, you've got a base on your hands. In a nutshell, bases are proton acceptors. They're responsible for the slippery feel of the soap when you're scrubbing away dirt. Now that we've understood what acids and bases are, let's summarize what we've learned. In our journey into the intriguing world of chemistry, we've met two significant players, acids and bases. They're everywhere, from the food we eat to the products we use every day. Our understanding of them, as we've learned, hinges on their behavior towards protons. Acids, the tangy-tasting substances, are known as proton donors. They willingly part with a hydrogen ion, a lone proton, when they come into contact with other substances. This ability to donate protons is what makes them acidic. Some common examples include the citric acid in your morning orange juice and the acetic acid giving vinegar its pungent aroma. On the other side of the ring, we have bases. These substances, often bitter to taste and slippery to touch, are eager proton acceptors. They readily snatch up any available hydrogen ions, which is what gives them their basic properties. Think about the soap you use for washing your hands. It's basic because it readily accepts protons. And let's not forget our little chemical spies, indicators. These substances change their color to tell us whether we're dealing with an acid or a base. Isn't that clever? So, next time you bite into a sour lemon or wash your hands with soap, remember the fascinating world of acids and bases you've just explored.